All right, we're going to look at a few functions and see if we can find their domain, and then see if we can find the values of the function with different inputs. Okay, so here we have a linear function, and it's asking us, hey, what's the domain? Well, what numbers can we plug in here? Can we plug in positives? Yes. Can we plug in negatives? Sure. Can we plug in 0? Yeah. Okay, so our domain is all real numbers, or you could say negative infinity to infinity, however you want to say that. What is f of 2? Well, f of 2 is just saying I'm going to replace x as my input. Okay, so I'm going to say 3 times 2 minus 5. So 6 minus 5 is 1. Now, this notation really confuses people because if we put in a number for our input, everyone goes, okay, that makes sense. But whenever you put in an expression for your input, everybody freaks out. And that's okay. It's a little complicated, but it's the same concept. So look what I did here. I put my 2 where my x went. I said, okay, taking away this x, I'm putting a 2 there instead. So I'm going to do 3 times, instead of 2 or instead of x, what did it say it wanted for my input? It wanted x minus 1. So I'm going to put x minus 1 as my input. And then I just finish. So instead of having my x there, I had x minus 1 because that's what it asked for. So I'll distribute this, 3x minus 3 minus 5, 3x minus 8. So f of x minus 1 is an expression, not just a number. Okay, let's do the square root one. This is where we really start to have to be careful about domain. Okay, so can x be positive? Yes. Can x be negative here? No. And we need to be even more specific. So in the parent function, square root of x, okay, what's our no-no here? We can't go negative. So this value right here can never go negative. So x minus 4 has to be bigger than 0. Okay, so if we adjust this, this is saying that x has to be bigger than 4. So I want you to think through this again. We know that this value right here has to be positive. It has to be greater than 0. So as we solve this, we see x is greater than 4. And that makes sense. Greater than or equal to 0. Because what's 4 minus 4? Well, it's 0. So 4 is fine. Anything bigger than 4 is fine. But the moment that this gets smaller than 4, that's where we wind up negative and out of the real numbers. Okay? So our domain is this. It's x has to be greater than or equal to 4. So we start at 4 all the way to infinity. Okay. So very similar to the domain of just square root of x, which is 0 to infinity. But this minus 4 adjusts it just a little bit. All right, f of 5. Okay, what's 5 minus 4? That's 1. 5 minus 4, square root of 1 is 1. F of x plus 3. Again, this confuses a lot of people, but what I'm going to do, let's just write the original. And then what I'm going to do, I'm just going to scratch this out. Say, that is no longer our input. Instead, we're going to put x plus 3. So 3 minus 4, that's negative 1. So this is what we get when we put in x plus 3 as our input instead of just x. Okay? This guy up here, this is a rational function. Again, our domain here, let's look at the parent function, 1 over x. So what is not allowed to be here? We have positives, we can have negatives, but we can't have 0. You cannot divide by 0. So we simply say x plus 3 can't be 0. And when we adjust this, we get x can't be -3. So our domain can be everything but -3. So all the way from -infinity all the way to right next to -3, union -3 to infinity. Basically, there's just a tiny little hole here with where -3 is. So everything below -3, everything above -3, but there's a hole there. Because what happens if we put -3 here? -3 plus 3 is 0. 1 divided by 0 is undefined. It makes no algebraic sense. So we leave that out. Okay. F of 3. 1 divided by 3 plus 3, that's 6. Okay. F of x minus 4. Again, just write out the original guy if you need to. And then just say, no, I don't want this anymore. I'm going to change that input. Change it to what? X minus 4. So 1 over x plus 4 plus 3. X plus 4 plus 3, that's just x plus 7. So that is the value of our function when we input x minus 4.